Okay, so in this video, we're going to look at how to transform functions. You should have this set of notes right here somewhere, either as a PDF or a paper copy. But these are what are known as parent functions. Right? You don't have to really memorize these, although it would benefit you to kind of have a general idea for what an absolute value function looks like, or what the cube root function looks like. But what we're going to be playing with is how to move these functions around, or how to transform them. Transformations are when you move something up, down, left, or right, or when you reflect something. Like if you take this and flip it across the y-axis, this part would go over here, that part would go over there. That's what a transformation is. We're going to learn the rules for how to do that. So you're pretty familiar with linear functions already. Y equals x, that's this one. Y equals 4x plus 3, the graph of this would still be a line, but it would just be like a transformation of this. Instead of starting at 0, you would start off at 3. And the slope, instead of it being up 1 over 1, well, the slope would be up 4 over 1. So the idea behind a parent function is that it's the simplest version of a function that still satisfies whatever the definition is to be that function. All right. So all quadratics will have like a U-shaped graph, whether it's y equals x squared, or y equals 4x squared, or x plus 3 squared. They're all going to be some version of this whenever you go to graph them. Now, on the other side, the next page of your notes, this is going to be the meat. This is the important part. These will be the rules that you want to be familiar with. You'll want to memorize them. All right, especially these first 6 right here. These are going to yield you a lot of benefits besides just our immediate lesson. All right, this talk about functions is going to apply to all sorts of functions, literally all functions. But so if you want to move something up, down, left, or right, it's as simple as adding or subtracting a number. So to move something up or down, you're going to add or subtract on the outside of the parentheses. That's how you do that. Okay. If you add something, it moves it up. If you subtract outside the parentheses, it moves it down. If you want to move it left or right, it's actually a little counterintuitive, all right? It's a little backwards from what you would normally think. Adding a number on the inside of the parentheses, that's actually going to move the function to the left. I'll try to explain why here in a second. And if you want to move something to the right, you need to subtract on the inside. Let's go ahead and look at an example of this. So I've got this quartic red function here graphed. And what I want to do is I want to move it 3 units to the left. Okay. So the rule for moving to the left is you have to add on the inside of the parentheses. So that's what I'm going to do. I'm going to do f of, let's say I want to move it 3 units over. I'll do f of x plus 3. Now, the reason that it moves to the left when you add, it's actually because you're kind of giving all of its x values a head start by adding 3. So right here, it took it 2 x values to get to a y value of 4. But whenever you increase those x values by 3, when you give them a head start by 3, it doesn't take them 2 units to get to a 4. It can actually get there with a negative 1. Right? It gets there 3 units faster. And so graphically, if you're giving everything a head start, you get to the y value that you were trying to get to, just you get to it faster. Right? So if you add something, it moves it to the left. And let's say you add something on the outside. Let's say we do plus 2. It's going to be the exact same picture, but shifted 2 units up. That's the idea. Now, this is what we would call function notation. Try to illustrate the difference here. So this was that function that we were playing with. And we looked at f of x plus 3 plus 2. And the rule, or graphically what happened was, this part moved it 3 right, and this part moved it 2 up. This is what I'm going to call function notation for how to do this. I don't really have a good name for this other form, but it's like the real form. I'm going to call it algebraic notation. And it's what you would get if you actually spent the time simplifying. If you actually spent the time simplifying this expression. So we've done this before. What you would do for this is you would go to the f function and replace these x's with x plus 3's. So that would give you x plus 3 to the 4th minus 2 x plus 3 to the 3rd, and then you have that plus 4. All right, that represents that part. And then this plus 2 after the fact, well, you just add that on after the fact, right? So if we were to graph this, it would match that blue function where we had graphed that, right? This is just the raw version, the algebraic notation for what this function notation means, okay? So you're gonna have to be able to work it both ways. Recognize, what's happening to the function if I give it to you in function notation, and you'll want to be able to spell that out algebraically. Now, I'm not actually going to work this one out and simplify it because it would be a mess, because you'd have to multiply this thing by itself 4 times. It would be a lot of algebra work to get that done. All right, let's go ahead and move on to our next example. All right, what I want to do is I'm given f of x is the square root function, and I want to simplify and graph f of x minus 5 plus 3. So to simplify it, this just means we're writing it in algebra form, algebraic notation. So instead of the square root of x, I'm going to have the square root of x minus 5. All right, I'm replacing that x with x minus 5. And that's happening inside the function, inside the square root, all right, inside the parentheses. And then this plus 3 just happens after the fact. It happens outside the square root, plus 3. And so what we want to do is we want to graph this. That's what we're trying to do. Well, if you recognize the function rules, minusing 5 on the inside, that's going to move the parent function 5 to the right. And adding 3 on the outside, that's going to move it 3 units up. So if we want to know what the graph of this looks like, it's going to be the exact same as our square root function, this one, but it's just going to be moved around. It's going to be moved 5 to the right and 3 up. So here's 5, here's 3, and the graph of it's going to look something like that. There we go. Okay. Let's sketch the graph of the absolute value of x plus 2 minus 6. Now this one's not spelled out for us in function notation, but it's spelled out in algebraic notation. So of course the original function was just the absolute value function, but what they've done is they've replaced the x with an x plus 2. So what that does, because we're adding 2 on the inside, is it moves it 2 units to the left, and they're minusing 6 on the outside of the absolute value bars. So that's going to move it 6 units down. And that's all we do. We're going to take this absolute value function and move it 2 to the left and 6 units down. All right, all the rest of it, all the scaling and stuff, that hasn't been touched. All right, 2 left, so that's -2. 6 down, it's -6. And it's going to have that V shape. There you go. And so a lot of times what you'll have to do is you'll be given the graph of it, and you'll need to work backwards and write the function. Just recognize from the picture that this little vertex has been moved over 2 and down 6. And then you would have to write that out in the actual form, not function notation, but in algebraic notation. All right, what expression would translate 1 over x, 3 to the right, and 6 up? Okay, so the first thing I'm going to do is I'm going to write this part. I'm going to write this out in function notation, what it would be. So 3 to the right is going to be f of x minus 3. You subtract from the inside, and then 6 up, we would add 6 on the outside, and that is our answer in function form, in function notation. But over here, I'll write my actual answer, right, in algebraic notation. I'm going to replace the original x with an x minus 3. So it's 1 over x minus 3. And then after this, after I do that part, I'm just going to plus 6. Okay, and that's it. That's my answer. I'll show you on Desmos real quick. All right, there's the graph of 1 over x. And if we look at the graph of 1 over x minus 3, that shifts it to the right 3 units. And then after, we'll plus 6. And that just shifts it up. I think that's it for this one. Yep. All right. So you'll need to be able to recognize translations, whether they're given to you in function form or in algebraic form. Okay. Or just given the graph even. Man.